Okay, so transformations of quadratic functions. We're going to explore some, we're going to take some notes. So you should have done the Desmos activities, which have you walk through changing the constant numbers in that quadratic formula. So x squared is our parent function, so we're going to be multiplying by numbers greater than 1, less than 1, adding and subtracting to the input and to the output, doing some negative numbers, and see what that does to the parent function. So these notes are kind of long. I think I have 20 slides, and I'm going to be inserting other slides with Desmos. So that's why this video is good. You might want to stop, take a break, kind of think about what was said or done, go get a drink or snack or whatever, and then come back and pick it up. This is a lot to watch all at once. If you try to do that, I don't even know how long this is going to be, but this is going to easily be a half hour, 45 minutes of me talking. Boring, 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 I know. So I would break this up. I would not try to get everything at once, okay? Because you're going to need time to think about it. Once we do something, you might say, I wonder if that always works. Go back to that very first Desmos. It's just one screen, and it lets you move the sliders A, B, C, or D. Go ahead and do that and see if it really happens the way we're going to say it happens. Okay? Before you start sending me a bunch of emails that says, I don't understand, this is hard, take a minute, think about it. Do the other two after this. There are two more Desmos that kind of that you can choose from, so that you can play around and just see what happens. Okay, so I need my parabola to be wider. What should I multiply by? Which number should I change? Kind of play around with it a little bit, because then you'll know what questions you really have versus I just don't get any of this. Okay, because I'm going to tell you it's a lot. Okay, I don't think it's particularly hard. A lot of these transformations work the same way the geometric transformations worked last year. It's not hard, but it is a lot of information. Okay, so that's just a forewarning. I would not sit down one shot, take my notes and say, okay, yeah, now I get it. All right, so not a big deal. I would break it up into chunks, okay, which is probably what we would do if we worked together. I probably would not do this all one day, okay? All right, so let's get started. So our TEAC is A7C, and this is what it says. Determine the effects on the graph of the parent function, which for quadratics is f of x equals x squared, when f of x is replaced by a f of x, or multiplying by a number, f of bx, or multiplying the x by a number, f of x minus c. So we are subtracting a constant. Notice that already has a subtraction sign, and we've seen that before. And f of x plus d, so we're adding something on to the end, okay? So that is our readiness standard. That's what it says. But what the heck does that mean? Here's what you're going to be able to do, what you need to do by the end of all of this, in kind of more plain English, is you're going to be able to graph a quadratic function. Now, we're going to use Desmos, so definitely graphing with technology, huge plus nowadays. You know how to graph a quadratic function. We talked about that in one of the notes from last week, where we just pick values for x, substitute them in, get values for y. You need at least 3 points to get a parabola. Okay, later on next week, we're going to talk about how to graph, being as now we know things like where the vertex is and what it means, the axis of symmetry, x-intercepts, y-intercepts, so we can graph other ways by hand as well. So you should be able to do that. And for this lesson, saying, yes, I can do that, I can use Desmos, great, fine. Okay, and then the big learning target is you're going to use a rule to describe a transformation. Sounds just like the TEAC you did last year in 8th grade math, but instead of transforming geometric shapes with translations, reflections, dilations, and rotations, you are going to be transforming the parabola. Okay, and we're going to talk about translation, reflections, and dilation, and that's what that stretch or compression is. It's a dilation. We're not going to like rotate these parabolas. That doesn't really make sense for this. But translation, reflection is going to look just like it did last year with the geometrics. And then the dilation will be a stretch or compression, and we'll get to what those words mean later. Okay, so the first thing we're going to do is go over again the parent function for quadratic is f of x equals x squared. Okay, so the coefficient is 1, there is no middle term or last term, and it's just the very basic parabola that goes through the origin and opens upward. Okay, so we're going to be adding, subtracting, multiplying input and output by different values to see what happens to the graph. Okay, I'm going to use Desmos because we all have access to that. Okay, so I'm going to add a page to go to Desmos. So at home, if I were you, I would open up, add another tab, and open up a Desmos screen. Okay, let's see. That should work. I'm going to go back and forth. If I were you, I'd have my notebook open so I could jot some things down. I will share this PowerPoint with you, though, the way it is, so you maybe want to open that and take notes on that as well. Maybe you just want to listen to the whole thing first and then go back and take notes. It's up to you, but I would graph along with, okay? And I'm going to pause here and there for what do you notice. If you are getting behind because I'm going too fast, then pause it, do what I asked you to do, see if you can get that to work, and then come back and listen again, okay? All right, so let's add a Desmos page. I'm gonna just go again to Desmos, and it's gonna search for me. I'm gonna click here and start graphing. Okay, so on my Desmos screen, I'm gonna first graph the parent function, and let me bring up my, hang on a minute, sorry, hold on. Okay, I didn't have my slideshow open on my desktop. So I'm on slide 5 now, investigation A. It says open Desmos and graph the parent function as f of x. So we are going to graph that just that way. Sorry, I'm looking at my choices here. I'm going to go just do f. I need parentheses, which I guess are here, right? Yep, of, oh, x is there. X equals x squared. Okay, and there it's going to give you that nice red parabola, very basic, opens upward, goes to the origin. If you try to do key attributes here, it's not very exciting. Let's see, the x-intercepts zeros are 0, 0. The y-intercept is 0, 0. The minimum is 0, 0. The axis of symmetry is x equals 0. The minimum value is 0. The vertex is 0, 0. And the domain is all real numbers. And the range is y is greater than or equal to, you guessed it, 0. Okay, so it's not very interesting. It's just our very basic, most basic form of our function we can have. Okay, so now it says we're going to add 2 to this parent function and see what happens. So it says click on plus, that's right here, plus sign. And you're going to click on f of x expression, and that's going to give us another line. It's like hitting tab on the Inspire calculator. So I want to add 2 to my function. So it says type in f of x. So f of x, and I'm going to add 2. So I'm just going to say plus 2. And I get a blue line. So now, what did you notice? What happened? So I'm going to give you a minute. And if I were you, I'd pause this video, but I am going to just make some dead air here if I can possibly be quiet long enough to do that, so that you actually have a minute to notice. So what do you notice about the equation? And then what did that do to the parent function? Okay, so that was about 30 seconds. So what do you notice? Well, I noticed the function added 2, and I noticed that my parabola shifted up 2 units. Okay, so just like, can I write on here? Ooh, I can. So just like when we did translations with geometric figures, adding will shift it up. Okay, so if I add, I'm going up 2. I went 2 units up because I have a +2 right here. Okay? All right, so the next slide says delete all functions other than the parent function by clicking on the X's. So I'm going to go undo my writing here so that doesn't bother us. Okay, and then it says to undo everything. We only have one thing here. Okay, we used to do all this. Uh-oh. Oh, I'm not on my little hand. Maybe. There it goes. Okay. So, there's my little eraser because now I put dots there. Okay, so then it says we're going to subtract 3 from our parent function. So I wonder what that's going to do. Kind of have an idea in your head. What do you think that's going to do? Again, we're going to add, maybe, plus, expression, and then we're going to take our function, so f of x, x, there we go, and we are going to subtract 3. Did it do what you think it was going to do? Okay, so again, what did you notice? What happened in the equation? What happened on the graph? Okay, so I noticed I have a subtract 3 here, and look, my parabola, the vertex on my parabola, my y-intercept, actually moved down 3 units. It's 3 units lower than what it was, which makes sense to me because I'm subtracting 3, which is going to change the vertex is going to shift it down 3 units. Okay, all right, so let's go to the next screen, but I think I'm going to have to skip 2 because I want to talk about what did I affect, the input or the output, and how do we know. Okay, so here it's like every point is 3, and one of the Desmos does that for you. You can see this point went down 3 units. This point went down 3 units. So every point shifts down 3 units. It's just easiest to see with the vertex. Okay, one more. There we go. So I'm going to hopefully erase here what I've done. Well, no, I can't. Did the what do you notice? We took this page. All right, so going. So sorry about that. Okay, so here we go. All right, in blue. What did you notice? You can do that. We noticed that when I added 3, or when I added 2, it shifted up 2, and when I subtracted 3, it shifted down 3, the whole parabola, so like the y-intercept, the vertex. But if we look back, going back. All right, so did we affect the input or the output? Okay, well, let's look. Did I subtract 3 from the entire function or just the x? You see how this is on the outside? That means we affected the output. We subtracted 3 from the entire function. That's the output. Okay, so these are outside parentheses. This is the easiest way to remember this. Outside the parentheses means you are doing things to the entire function, which means you're affecting the output. Because I'm affecting the output, which is on the y-axis, that's why I'm shifting up and down. Okay, so the output, oops, so sorry, the output is the y, right? Dependent, range, output, y. So the output is the y variable. That's not a very nice y. So sorry. So the graph moves vertically up and down, depending on whether you're adding or subtracting, whether you have a positive or a negative. Kind of like when the geometric translations, when you did things like, let me add a page. Now you have a function, you're adding to the entire function, you're taking this whole function, subtracting 3, or adding -3, and a negative will go down in the negative direction 3 units. Okay? If you are adding, if I take my f of x and I add 2, well, now I'm taking my whole entire function and adding 2, which is going to shift it up 2 because I'm affecting the output. How do I know it's the output? Well, because it's outside the parentheses. Okay, and that little, whatever you want to call it, mnemonic device, whatever that's called, that's how you can remember. Okay, because that's anytime I answer, and then whether it's the input or output is going to be important later. Now, if all else fails, get your graphing calculator or open a decimal screen if you're at home, graph it and see what happens. You know, I don't know, did it go up 3 or down 3, or did it go right 3 or left 3? I'll graph it and see. Okay, so that's the good thing about having a graphing calculator. Okay, because these will look different. A little bit later, it's going to be really important that you know whether it's input or output. Okay, all right, so I made for you, and I will link all of these in one document as well. See what I mean? Change had a rule. This is what it looked like last year. Oh my goodness, I'm getting ahead of myself. This is what your translation up and down looked like last year. Okay, that would translate your figure up 3 because the y goes up and down. Okay, same thing here. Because I need plans. Little posters. Okay, I'm actually kind of excited about these. Okay, so to translate up, the parabola is going to move up because the output is affected. So here's your rule here. So this is, if you remember that first slide where we had the t, it has said f of x plus d. So I am adding something to the output. That's going to move it up and down vertically because the output is the y and the y-axis is vertical. If it's greater than 0, that means I'm doing f of x plus a number. It's going to go up, which makes total sense since up is, positive direction is up. Okay, this rule says the same thing, but if it's less than 0, I'm going to have minus a number because, you know, we don't in algebra put plus a negative. Okay, so I don't remember what I was saying, but I was trying to make that a negative sign. So negative would move down in the negative direction. Okay, all right, so that's all about the output. Again, when in doubt, graph it and see what happened. To graph the parent function, graph the new one you're given to see did it move up or did it move down. Okay. All right, and a lot of these questions, when I looked at release questions, they give you the graph. Sometimes they give you the graph, and sometimes they give you a description. So in the practice that you're going to do, it's like it's a nearby matching, the first one. I did both. Either you match the graph in the equation or the description in the equation. Okay, so this might be a good time to take a break and think about it, or go back and maybe make some notes. But of course, I'm going to keep on keeping on here. All right, so let's go back here. See what's next. Next, we are going to do another investigation. So we're going to delete everything out of decimals again, other than the parent function. And now we're going to add 2 to the input. So notice here, before I go to the decimal screen, input, and look, I'm inside the parentheses. Because what this would mean, if you remember way back long ago when we did functions back in, I don't know, September-ish, and we had to evaluate functions, that means put x plus 2 in for every x you would see in the function. So I'm adding 2 to the input. How do I know again? Because it's inside the parentheses. Okay, so let's see what this does. Kind of think about what do you think it's going to do? And then let's see if you're right. All right, so I'm going to add, think about that decimals page again. I guess I'll just go, let's see if it will, decimals, graph. I guess I could have went back to my other screen. Oh well. Yeah, let me do that. I'm going to start again. But you can just delete delete what you need to. And now, of course, this is not working. There we go. Oh, there's a little picture. That's interesting. Okay, so sorry. So let's go f of x equals x squared, because the first thing we need to get in here is our parent function. Yours will already be in there. And then I'm going to add another expression, and this time I'm going to take my function and I'm going to add 2 to the input. Okay, so think about what you think is going to happen. Oh, it shows you already. So did what happened happen like you thought? I bet if I would have asked you, you would have said it was going to go to the right. But look, we went to the left, and this happened. I'm trying to think of, this happened a couple times throughout the year, and I said, remember, it's x is minus c. So if I am subtracting c, that means c here must have been negative. Okay, so remember, we talked about this, and I'm stalling because I cannot remember when it came up. Oh, it's a total blank. I don't know, but I know it did, because I said, oh, it's going to come up later too. Well, this is that time it comes up later. If you remember, you are welcome to comment and say, hey, it was when we did blah, blah, blah. All right, so we have x minus c. That means c had to be negative in order to get a plus here. Okay, so the rule has a subtraction sign in it already. So in order for that to be positive, sorry, in order for that to be positive, c had to be negative. Well, negative numbers move us in the negative direction on the x. Okay, so I went 2 units this way. Okay, so the next screen then says I'm going to subtract 3. Okay, and what do you notice? And again, we are affecting the input here because this is inside the parentheses. So it's the input. So we are talking about moving along the x-axis. Okay. All right, so let's go and look at, sorry, the slide. This slide. Okay, so what did you notice? It moved to the right 3 units. Okay, it's the input, and how did I know? Because it's inside the parentheses. Okay, so just make sure, once again, and let's make sure we're right. So now, let me put my parent function in here again, because if I go back, it won't let me erase the writing I did on the other graph. But you can, of course, just delete the one that you did and then add, or you can just go back actually and change the +2 to a -3. You don't have to write it all over again. X, and now I'm going to subtract 3. And look, it moved to the right because the rule says f of x minus c. So in this case, c has to be 3, positive 3, which makes it go in the positive direction. Okay, so that that is something a little bit tricky you have to pay attention to. Since that negative sign is already in there, that means c had to be positive. Okay, all right, not that. I'll come up on that. Let's go back to the next slide where I made little posters. You're gonna go right, and I know this says -3, but it's because if that's a negative sign, this means c is positive, because the negative sign is already part of the rule. Where over here, this is positive, that means c must have been negative in order to get the plus sign there, because minus and negative, and that's what I kind of tried to show you right here. Okay, so it goes opposite of what you would think necessarily. Again, the important thing is that this is input, so you're talking about moving along the x. And again, you can just graph these and you'll see. You might say, wait, I think that's going to go right. And then you graph and you're like, oh no, it went left. Not a big deal, okay? So these you can totally, again, just like the other ones, graph to see what happened. And just like in the geometric translations, when I add to the x, I go right. When my value is positive, when my value is negative, I go left. The only difference with quadratics is the rule already has this negative sign in it. So it's kind of going to look opposite, okay? All right, again, I might take a break now and kind of look at my notes. I might go back at this point and go, really? Is that really going to happen? And go back to that Desmos, that very first one where it had the sliders, and just kind of move things around and see what happens. Okay, see if you can try some positive values, some negative values. Guess what's going to happen? Move the slider and say, oh yes, that happened, or no, it didn't, and why. Okay, because remember, this is not just about writing down notes and filling out things and getting grades. You have to learn, okay, and you learn by doing. Okay, I was getting ready for this one. So now we're going to multiply the output, multiply our function by -1. So how do I know it's the output? Well, because it's on the outside of the parentheses. So let's go see what that will do. I'm already starting a new one. Okay, so I think we're here. Hang on until I get my dogs out. Out. No. Hang on. Okay, sorry. So I believe. So I'm gonna add. Oh, no, that's not what I meant to do. Weird. Okay. Hang on. All right, so let me go again. F of x equals x squared. Okay, and then I'm going to add, there we go, another expression where I'm going to multiply by -1. So I'm just going to go negative. You can put a 1 here if you want. 1 if you want. Or you can just put the negative sign of x. X. And look and see what happened. So it just kind of flips over. And we talked about that earlier, I guess in the first note about opens up or opens downward. The negative sign will just reflect it over the x-axis. So what happened was I multiplied the output by -1. So if you think back to your geometric reflections, the geometric reflection would look quadratic. It reflected over the x-axis because it went from here to here. That's over the x-axis. And what happened was I made my output negative. So that means all my y's are now negative. So that flips it over the x. Okay. Again, you can just graph this and see what happens, and that would be enough. Okay. So let me undo this writing, because now the next slide is going to ask us what happens if instead of the output, I now multiply the input. Why does it do that? I just wanted to change one thing. Okay, well, these were the roles, x, y, my fingers are sticking, I'm cold. Okay, equals, if it's going to go over the x-axis, then the x's are going to stay the same, and the y's are going to be their opposite, and that's what the rule would have looked like. Okay, so let's go back to this now wants to know what is going to happen if I change my input to a negative, if I multiply the input by -1. Okay, so input, that's the x. I'm going to change the x's to their opposites. So think about what that's going to mean. If you think about, or remember, whatever word I want to say here, if my y is x squared, then if I have -2 here, I get +4. If I have +2 here, I also get +4. So I wonder what's going to happen to the graph. Let's see. I'm gonna show right now. Maybe if I can get my act together here. A Desmos screen. Start the graphing. And we're gonna start with f of x equals, oh goodness, my fingers are dead. X equals x squared. Okay, and then we're going to add another expression, and this time we are going to multiply our input by -1. So this time I'll just write the negative sign, you'll see, same thing. So what happened? The line turned blue. Because now all the x's went to their opposites, but because this is a parabola with this nice little line of symmetry, it's just gonna flip over the y-axis, so it's gonna end up being the same, only like this part of the blue line is really this part of the red line, if you know what I mean. So it doesn't look like anything happened, because you multiplied the input by -1, it's reflecting over the y-axis. Just like in geometric transformations, if I reflect over the y-axis, the y stays the same and the x changes to its opposite. Okay, so if you do that in a parabola, being as it has that axis of symmetry and it's the same on the left as it is on the right, the left and right just switch places and it looks like nothing happened. Okay, you don't see that happen too very often. Usually it's the reflection over the x-axis, but you know, while we were talking about it, we might as well look at everything that could possibly be happening. Funny you should ask. Okay, so here we have handy dandy little charts again. So if I reflect over the x-axis, I'm flipping over the x, the output is affected. And so the a is on the outside and a is less than 0, which means it's some negative number. Could be -1, could be -0.5, doesn't matter. Okay, if I reflect over the y-axis, it's going to look like nothing happened. And if you look real close, I made my parent functions dotted. Only because, by the way, I did that because one of the star questions has the parent function dotted in, which is not what I would do. And I think I did answer that wrong when I was looking at it the very first time I saw it. To find out, you know, I look at it to see what could kids possibly do wrong. Well, that's what I did. So I made them dotted, and here you can see there's a dotted line, but if you look real close, you can see a blue line laying over top of it. Okay, so if I reflect over the y-axis, it flips over the y, so it looks the same, so they lay over one another. Okay, the input is affected, so that's b, that's a different variable. Okay, how do I know it's input? Because it is inside these parentheses. How do I know it's output? Because it's out here outside the parentheses. Okay? All right, so that's the translation and reflection. Pretty much, if you ask me, works the same way geometric ones do, except for that whole, you know, translating along the x-axis, you have that rule x minus c, which kind of makes it look like it does the opposite of what you think it would do. And that brings us to the dilation portion. So I want you to think back when we did linear equations and functions. At some point, either this year or maybe even last year, you talked about if the slope was bigger, like maybe 3, a slope of 3 would be pretty steep. And a slope of, say, 1/2 or 1/3 would be kind of flat. So the bigger the absolute value is of the slope, the steeper it is. And the lower it is, the flatter it is. And then, of course, the positive negative just flips it around, you know, from going up to coming down. You know, puff, puff, positive, nice, negative kind of things. Okay, so keep that in mind as we do this next section. Okay. All right, so we are now going to start multiplying by scale factors and seeing what that does to our line. So we're multiplying our parent function by a scale factor, and look, it's on the outside, so that means we're going to affect the output. Okay, so let's take a look and see what that does. Kind of take a guess while I'm going through here, trying to add this, or maybe, I'm sorry, you're ahead of me and you're doing it and just waiting for me to catch up. Or maybe you have paused me, not a bad idea, and do this to see what you notice. All right, start the graphing. And again, I'm going to start with my parent function. And I'm typing it in function notation so I can easily do things like multiply it by 2 without, going through evaluating the function necessarily. Okay, so there's our nice parabola. I'm going to multiply the entire expression by 2, right? So 2 times f of x. F of x. X. Okay, so that's the blue line. So what happened? How would you describe that? I think our first inclination, for me anyway, I would say it got narrower. Okay, and if you think about that, well, a slope of 2 would be greater than a slope of 1, and it would make the line steeper. So it kind of makes a parabola steeper, maybe you want to say. Like it just brings it closer to the y-axis. Okay, and then the next slide asks us to, let me go and I'll together for whatever reason for this one. So if I go back and I add, or it's not going to let me. Okay, so let's add, or let's start again, f of x, x equals x squared. Okay, if nothing, you'll definitely know what the parent function looks like, right? Okay, add, I want to add an expression. Now I'm going to multiply by 1/2. So think about what you think might happen. Oh, hang on. No, 1/2. I'm multiplying the entire function by 1/2, which you could just do as as 0.5 if you wanted to. Okay, so now what happened to that blue line? Instead of getting narrower, it got wider, right? So it got, like if it was linear, it would get flatter. So I kind of flattened out my parabola. So we would say it got wider. So here's the thing, that used to be enough, and that's how we describe these transformations, as it got narrower or wider, and life was good, and we just went on with that. However, what they really want us to do is describe what happened versus input versus output. So what happened? So these parabolas, we talked about the output. How do I know it's the output? Well, because I'm multiplying by things outside the parentheses. So since I'm talking about the output, I'm going to talk about what happened to this parabola in regards to the axis that deals with the output, which is the y-axis, which is the vertical axis. So when I describe what's happening, I'm starting with the words vertical. So I'm not going to look at what's happening along the x, doesn't matter, because I'm doing output, which is y, which is vertical. Okay, so let me go to that screen. Asks us to multiply, there I make a mistake. Asks us to multiply by 1/2. So you really need to type 1/2 f of x. Okay, so now you can do that separately if you want. I'm just going to go ahead back and put it on the same graph so that I can. No. Oh, am I affecting input or output? Okay, so I'm going to. Let me another one. So maybe I can talk about this. Made it narrow, and this made it wider. We are talking about the output, which is the y, which is the vertical axis. Okay, so if, let me put my, it's red, right? The parent function turns up in red, and blue was, I'm going to do the narrower one. So in regards to this y-axis here, in regards to this. That's what I'm looking at. What happened? We call this a vertical stretch. Okay, now here's how I remember it. I am stretching this function out along the vertical axis, so it's coming closer to the y-axis. Okay, so I am moving away from the x and stretching it along the y. Okay, so this is called a vertical stretch. Okay, because I'm only looking at what's happening along the y-axis, so I'm stretching it out there. Okay. Now, and yes, I'm sitting at my desk, like stretching my arms like up above my head, stretching, getting narrow, stretching to the ceiling. So if we do, and if we were together, we would do quadratic, what did we call it? Quadratic yoga, I think is what Mrs. Castor and I called it. So if I make a U shape, like with my arms, just a regular U shape as the parent function, if I make it narrower, I'm stretching up to the ceiling. Okay. Conversely, if, let me use green here, if it gets wider by the 1/2, I am compressing it away from, so I'm pushing it down, compress. If you compress like soil, if you're putting in like a driveway or something, you got to tap down the soil so that water and air doesn't get underneath it, so you're compressing. I'm pushing it down towards the x-axis. So that's a vertical compression because I'm pushing away, okay? So the green one would be called vertical compression because it's going away. It's being compressed downward, okay? This vertical stretch is I'm stretching upwards along the y-axis because it's the output, so I care what's happened vertically. The y, the output, the dependent variable, okay? All right. And no. Okay, so here's your posters for that. Vertical compression. The parabola is moving towards the x-axis. The output is affected. The graph becomes wider. It's being pushed down. And that's when I have a fraction. So if you look at the rule, I'm multiplying by a number between 0 and 1. I'm not going less than 0 because, again, we're talking about kind of like with slope, that just changes the direction of the parabola. If I would multiply by -3, it's still going to get wider. It's just going to be flipped over the x-axis and wider. Okay? So I'm talking about numbers between 0 and 1, like all of those fractions and decimals less than 1. 0.2, 1/3, 1/2, 2/3, 5/8, 7/8, 0.963, whatever. Okay, it's going to get wider. If I multiply a times a function that's greater than 1, then it's going to get narrower and it's going to stretch out that axis. Like if I think about doing that with my arms, and now I'm narrower, I'm stretching to the ceiling. Okay? All right, so if it equals 1, of course, it's not going to change. It's just going to be the parent function and not interesting at all necessarily. Okay, so now let's look at what happens when we do the input. Okay, so now I'm going to multiply the input by 2 and then the input by 1/2. How do I know it's the input? Well, because it's inside these parentheses. Inside parentheses means input. Okay, and let's see what happens here. So let me add this mouse page. And start with my parent function again. So f of x equals x squared. Squared. There we go. Okay, and then I'm going to add an expression, and now I'm going to multiply the input. So f of 2x. And it looks the same, does it not? That is what happened when I multiplied the output. It got narrower. Okay? Interesting. I wonder what happens when I multiply by a number less than 1. But again, greater than 0, otherwise it's just going to flip it over the y-axis this time. So what happens if I do f of 1/2? Or did I do 1/3? I don't remember. I'm going to do 1/2 just because. Make sure your x does not get stuck in the denominator. That's a whole nother set of functions. Okay, and look, it got wider. So the same thing happens. So this was not a big deal a couple years ago when we just had to say narrow or wide, but it is a big deal when you are naming them as a compression or a stretch, because now we're talking about the input. And what axis has the input values on? The x, which is horizontal. So now we have to describe these compressions and stretches horizontally, okay? So let me go and see what the screen is. Okay, so again, 1/2. What did you notice? It got wider, okay? So go back and add a page here and talk about this. So, okay, so this in the same way, f of 2x makes it narrower. F of 1/2 x still made it wider. Still kind of thinking about slope, and the steeper slope would make the parabola kind of get steeper, closer together, and the slope that's less than 1 would be flatter, so it would make the parabola flatter or wider. Okay, so the difference here is we are talking about the input because it's inside parentheses, which is the x, which is the horizontal axis. So I need to talk about what these guys are doing, what these functions are doing horizontally. So my first example, it got steeper, so let me kind of redraw that here. Sketch, we'll call it, since that's not beautiful, but you get the idea. There's your parent function. And here is your narrower function. Okay, so I'm not going to talk about vertical stretch, even though it looks the same thing. Okay, so that's the trick here. They look the same. So you can't just graph it and know what's happening. You have to know what you're talking about here. I'm talking about the input, so I'm talking about horizontal. So what is happening to this in reference to this horizontal axis? Well, it's being pushed away from it. It's going towards the y. So it is being compressed away. You're pushing it away. You're pushing it, like, I know the vertical one kind of makes more sense because you're pushing it down, but now we're on the ground and we're pushing away from the ground. So if I'm pushing away from, that's a compression. Okay, so this is called a horizontal compression. If I would have a pen, you might be able to read it better. That's a horizontal compression, okay? When the scale factor for the input was less than 1, we again got a wider function, okay? But again, we need to think about what's happening to this function along the horizontal axis. So this is a horizontal, and you may have guessed because it has to be the opposite of compression, which is stretch. So here's how I remember this. I'm stretching this parabola out along the x-axis. Okay, so if I make a U with my hands again, now I'm getting wider. I'm stretching out left and right. Okay. And if I have my hands and I'm thinking about what's happening horizontally, like towards the ground, if I am getting narrower, I'm pushing up away from the ground. So I'm compressing to the y-axis, okay? All right, so you really need to pay attention to input-output, which I really don't think is a big deal. Inside parentheses is the input. Outside the parentheses is the output. And that's going to get you through this whole thing. That's all you got to remember. In means in and out means out. Seems pretty straightforward, okay? All right, so here's the posters for that. So horizontal compression, the problem moves towards the y-axis. The input is affected and it becomes narrower, so it's compressing away from, it's being pushed away from the x-axis, okay? And in that case, b is still going to be greater than 1, okay? But now it's a b because it's in the inside. The other ones were a's because they were on the outside. Not a big deal, but just in case you're wondering, well, how come now we're talking about b's, okay? All you need to know is if I see the graph, if I'm just given a graph and I say, hey, is that a horizontal compression or a vertical stretch? You're going to go, I don't know. because you have to see the function. Okay, and you're going to see that in a minute. So once I see the function and I know it's inside, I'm going to look for answer choices, or I'm going to be thinking horizontal. I need to describe this as what's happening to it horizontally. Okay. All right, and then this one, again, B is in between 0 and 1. So I'm stretching out along the x-axis. Okay, so you're stretching out along that horizontal axis. Okay. So here's the deal with that on this next.
Hey, Salji.
Mary, I'm gonna be muted because my dog is having a barking fit.
Okay.
Vertical.
You do what you gotta do. Just jump in when.
Sorry about that. Having a faculty meeting and I thought you wouldn't hear it. I don't know why, but I'm almost done here. So if you look at this, the vertical compression and the horizontal stretch looks exactly the same. So you really have to pay attention to input versus output. Okay, so vertical compression, horizontal stretch look the same. So again, you're not, if you are just given the graph, so you don't know what to call it, you need to have the function. So I see that this is output, so I'm talking vertical since it's output. How do I know it's output? It's the number, the multiplier is outside the parentheses. A is outside the parentheses. Okay? How do I know that this is horizontal stretch? Because if I look, it's the input, so I need to talk about horizontal. How do I know it's the input? The number, the multiplier, is inside the parentheses. Okay, and so the same thing happens with horizontal compression, looks the same thing as a vertical stretch. So if you're answering a multiple choice question and one of the answer choices is horizontal compression and one is vertical stretch, and you don't have a function, you just have a graph, then neither of those could be right, because you don't know until you have a function. I'm inside the parentheses, so I'm looking at a horizontal, what's happening horizontally. I'm outside parentheses, so I'm looking at output, I'm looking at what's happening vertically. Okay, so that's the biggest difference. Inside versus outside will tell you whether you're looking at what's happening horizontally or what's happening vertically, because a vertical stretch looks the same as a horizontal compression without functions attached to the graphs. Okay? All right, so make sure you've taken some notes. Again, you might want to watch this again. I think this is probably long, so I had to stop a whole bunch of times to attend meetings and whatnot. So I think I'm gonna revise our week schedule, our instructions, and I'll put information on that now. I think we're going quicker than we need to, because we just had the faculty meetings at about 20 minutes a day. I'm pretty sure this video is gonna be longer than 20 minutes. So next week then we'll pick up practice and things. That's where I'm thinking we're going, but I'll put information on the classroom so that you know for sure. Okay, let me know if you have questions.